Thanks for coming to my talk. It's called What Symfony Components Can Do For You. And I get to what that means in a minute. First, a couple of words about me. I am Andreas Hucks, or me and my monkey on Twitter. I work for SensioLabs as a software architect and trainer. We do Symfony consulting and training. I live and work for in Cologne, for the Cologne SensioLabs offices. That makes me German, not French, so don't expect too much jokes or humor today. What is Symfony? Or rather, who has worked with a full stack framework? Nobody. Okay. Cool. Yeah, figures. Yeah, of course. Who has worked with Symfony 1? Probably even less or none. Well, Ryan will have. KQ. Or Zen Framework 1 or any last generation framework at all. Well, more people, of course. Okay. So if you've worked with one of those full stack frameworks, the impression or the mental image that it will have when I say full stack framework is probably something like this. So it's a thing, it's kind of monolithic, got a lot of bells and whistles, and can do everything at once, but not really that sophisticated for every single thing. But it's not only a full stack framework. It's also, and this is the sentence that we usually use to define that on our website, Symfony 2 is a reusable set of standalone, decoupled, and cohesive PHP 5.3 components that solve common web development problems. What does that mean? Well, architecturally, from the big picture, it means that Symfony 2 is just a very thin, the full stack framework Symfony 2 is just a thin layer on top of a collection of components. And those components are dedicated to solving certain problems that are, well, part of your everyday developer life. That would be things like templating, routing, validation, creating forms, displaying forms, stuff like that, and they are designed to make your life a lot easier. And this talk is not about the full stack framework. The talk is about just the components and how we can use them in your code to improve it. Our example will be we are going to refactor a legacy app that we're going to come to in a minute. But first of all, the components are to varying degrees used in a lot of frameworks, other frameworks and projects. Actually, this list has grown quite a bit longer now. It's obviously Symfony 2, but it's also Drupal 8 uses it, Silex uses it, Laravel, the PPI framework, PHP Unit Composer, the console part that I'm going to show in this talk as well is used by Composer, for example. Lots of other software projects built on Symfony components right now. All right, so I'm going to walk you through an example project, a legacy project, and the scenery is this. It's Friday, and your boss wants you to implement this tiny little app for one of your oldest clients, and he wants it on Monday, but it's very easy because you've done that stuff. You've got that code lying around. It's a couple of years old, but your boss says, yeah, well, just use that. Throw a couple of new style sheets on it, and it's done. And what it is a to-do app that you are tasked with to refactor for the day, and yeah, I mean, what could possibly go wrong, right? Nothing ever does. And you open the code, and it has a couple of problems, more like every single one there is, you can imagine. All kinds of vulnerabilities. Presentation and controller code and business code is mixed, database access is embedded, configuration is hard-coded, stuff like that. So it's not really an option to keep on using that. And you see your weekend go and get kind of a sinking feeling. So what you do, you use the to-do app to make a list of things that you need to do. And the first thing is, which is like the starting point to refactor this all, to quarantine the code, the old code. So let's build a wrapper. Let's build a wrapper around the legacy code so that we are able to step-by-step refactor this using the Symfony components. It's very difficult. It would be very difficult to actually work those components right into those code. So what we're doing is we separate the legacy code from a new one by building a wrapper around it. And the first tool that we use for this is something called HTTP Foundation, which, by the way, is the most widespread used Symfony component. It is well, you could describe it as a OOP interface for HTTP. It wraps your request and your responses into objects. It it enables you to get rid of using superglobals. It wraps all your get parameters, underscore post, underscore cookies, and so on. All the superglobals you know. It also provides you with a couple of helper methods that are there more or less for convenience sake. A couple of those we're going to get to know today. So this is just a very simplified wrapper. Basically, what you'd want to have is something that can execute the legacy code in a safe manner. Part of that would be to replace the superglobals that it uses, or the global registered variables that it uses, and then you start a buffer and start the output buffer, capturing the output buffer, and you require the file, the original legacy file, and get the output, which would be the response body, of course, and then you create a response. So you have a request object. We will see in a minute how we create this. You have a request object, and that request object encapsulates all of those superglobals, and return a response object. Return a response object that contains your HTTP response. Now this is the actual front controller. If you've used Symfony or derived frameworks, you probably have seen something like this as a front controller. What we do is we create the wrapper, and then this is a line that you might recognize. Request create from globals. That means we create a request object that we could create manually and set the values manually, but we create it from globals. That means we read all the environment variables that PHP provides and create a request object from this. And from this point on, everything gets neatly encapsulated, object-oriented. We then hand the path info, which in our case is the legacy file name, over, together with the request object, over to the wrapper, execute it, and then send the response. If you've ever looked at a Symfony 2 base front controller, you will recognize a couple of these lines. Actually, they are quite similar. Now, what we've gained so far is just we wrapped our legacy code so we can start extracting parts of functionality and re-implementing them using the Symfony components. And one other thing that we gained that I'm going to talk about in a later chapter, but this is just an outlook for this, is testability and compatibility. Because if you closely look at this line, request create from globals, that means, well, this creates the request from the environment, but it also means that you could, of course, create that request by hand and inject variables of your choice. So what you're now able to do is to fake a request. And once you are able to fake a request, you can run functional tests from the command line, because you can now create artificial requests, run the framework or whatever you do to create a response, and then analyze that response object for a certain property, like assert there's a headline in this, or assert that the status code is 302 or whatever. But we'll get back to that later on. So far what we've kept is our URL structure, so our application is going to keep working. And yeah, we isolated the code, can be integrated in a new app, it's testable. So we can move on to the next point. And the next point would be to improve error reporting a bit. I call it make it report. And for that, we can use the next component, which is called debug, the debug component. And debug component is, well, the main job of the debug component is to smooth out PHP's error handling. You all know PHP has a somewhat flexible error handling. There's native errors, there's exceptions. There are objects like PDO, where if it's a native error or if it's an exception, depends on how you configure it. So it's really weird, and the debug component creates an error handler, an exception handler, and optionally a logging functionality. I can get to that later, and smoothes this out so you can work with the exceptions throughout your code. And it's really easy to use. All you have to do is register an error handler. Error handler register with a level that should be handled. And if you use the PSR 3 logger interface, then it's easily, you can just plug in any logger that even logs the errors. So it's very, very flexible in that way. Then register the exception handler register, debug true, and you'll end up with a clean error output that will give you readable exceptions. And you can wrap all of those codes in a single line. Just use debug enable with a level, and that's it. And your debug component is in use. By the way, I'm going to show you a link for example code to all of that at the end. So you can, if you'd like, you can reproduce all of this. There's a GitHub repository for this. So next step is routing. Actually, for the routing, I've split the routing chapter into 2 parts because there are several steps involved. And the first part for routing is what we want to do is we want to define routes as patterns. We want to be able to assign attributes to it, like which controller corresponds to what route. And we want to match an incoming URI to a route. So the router should look at that URI and come up with either with a route or with an exception. And the other way around, we want to be able to generate a URI from a route object. And there's several ways to do this, and the manual way to do that is to create a route object using a path. It's important to realize that in this case, this is not really a file name. I'm just calling this could be any path. I'm just calling this index.php to maintain my older URL structure. So this is going to keep working with the rest of the legacy code. In the long run, I would, of course, rename this to something else. But for this part, I'm keeping it with the index.php. And then I set defaults to those routes. And the default is, well, it's just an attribute. It can hold any kind of data. In this case, I'm calling it _controller. And the data I'm assigning in this case is a callable. I could just as easily assign a string or something, which is something that we're going to do later on. But right now, it's just a callable, which is in fact my controller. Wrapper, execute index.php. So what I've done now is I've used my wrapper and bound it to a certain route. Now when I've created several routes and added them to a route collection, all of this is part of the routing component, then I can create a URL matcher and match this path info of the request to this URL matcher and end up with a set of parameters. Those parameters are simply, it's just an array of values. And the match method will return this array or nothing if it doesn't match a route. And what's happening with these kind of information, with this array, is entirely up to you. Because this is a standalone component, now the part handing over this data to a controller, selecting a controller, is up to you. In our case, the controller, well, in this example it's a string, but in our last example it was a callable. So if we keep it with this callable, we could do something like this, where we take the parameters from the matched route and simply call it because it's a callable, and get the response and send the response. The URL still remains the same. It still is going to work with all the links in our legacy code base. So there's still a smooth transition. Let me see. Wait. Did I skip something? Sorry. Need to check something. What happened? Oh, sorry. Okay, next would be templating. Now that we can create a template, a route, and match it to a controller, we really want to extract all of that presentation logic. And what we're going to do is use the templating component from Symfony. It's a simple templating engine in PHP. Of course, I could just as well use Twig. In fact, I can use Twig together with that component. In our case, in this example, I'm on purpose just using PHP because this is just about the Symfony components. The simple templating engine allows me to use escaping and inheritance, and provides me with a generic interface to allow for easy engine replacement. So I've got this templating interface. My default implementation for that is the PHP templating engine, which is what we're going to use now. But I could just as easily switch this out to Twig, or evenly combine several engines, which is probably not a good idea, but which I can do. Let's look at the legacy code. This is what it looked like before. So we have classic includes, stuff like that. And we want to replace that with several more flexible templates. And has anybody used Twig so far? Okay. So you might realize the concept, which is simply that we have a layout. And the layout in this case corresponds to both our header and our footer from our legacy code. So the header would be here, the footer would be there, and then we have slots. And these slots can realize a sort of template inheritance. Template inheritance works by you can imagine that a lot like PHP class inheritance. In PHP class inheritance, you have a base class and you have a derived class, and the base class can have methods. And you can do in the child class, you can do several things with this class. You can, with these methods, you can do nothing. You can override them, or you can add new methods. And with the slots, it's very similar. In a template that derives or extends, in this case, the layout, you can do several things with these slots. You can either use a slot as it is, or you can override it. or you can add new slots. So in this way, you're able to assemble blocks of templates with the main content and so far. To set up this component is rather easy. You create a PHP engine, which is an instance, an implementation of that templating engine interface. It gets a template name parser, which is, in this case, there's a default implementation for that, which resolves the template names, and a file system loader, which could be a different loader. You could load your templates from a database or whatever. In this case, it's the default file system loader. And well, that's more or less it. After that, you can use the templating engine to render a template name, which then will be loaded from that file system pattern that you described. It could just as easily use twig, and you could keep that syntax to call the rendering of the template. If you've used Symfony or used twig, that will be familiar to you. Okay, so let's get back to just a second. Let's get back to the router, because now that we have templating, we want another feature of the routing, and another feature of the routing is what we've so far described is just the matching. But what we also need to have a routing make sense is the ability to generate routes. Generating routes means I have a route name, and in my template I can generate a URI from that route, possibly combined together with a couple of parameters. To get a URI, because only then I will be able to flexibly redefine my routes. And what I can do for that is use an all-in-one router. All of this can be set up manually in lots more steps, so it's very flexible. But for general use cases, there is a default router that combines a lot of functionality out of the box. One of those things that it allows you to do is it creates a generator for you that you can use. We'll see that in one of the next slides. But it also gives you the ability to register, to hand over, again, a loader. In this case, it's a YAML file loader. So you will be able to define your routes in a configuration file instead of in code, which is sort of more readable, of course. So we hand over a loader that can load one of those configuration files. We tell it what that file is named. Optionally, we can give it a couple of options. One of these options is the cache directory. So it can cache these routes that it creates from those YAML files to improve performance. And this YAML file could look like this. We could use different formats. YAML is probably the easiest in this case. You define routes under keys which correspond to the names that you can later use to generate the path for that, give it a pattern or a path. You can lock routes to methods, so they will only match if the HTTP method, for example, is post. And then again, you can set defaults. If you remember one of the earlier slides where we called set defaults to set this callable as the controller default. In this case, we use strings to identify a controller. What you use to identify controllers is up to you. The reason why we are going to use strings is something, well, we want to use controller classes in the end. Going to see that is one of the next steps. Now, the matcher and the generator are part of that router. You can get at them by calling getGenerator and getMatcher to use them. And if we now have a controller class, we again match the route as we did in the first place. We end up with a couple of parameters. But this time, remember, the underscore controller parameter is a string. So in this case, we use this to create a callable array with the controller class instance and the assembled action name that we want to call. And we also pass it the request. And again, we get a response. This is still just a step on our way to refactoring. This is going to get easier. It's just an intermediate step because we haven't introduced all of the components yet. So, let me see, sorry. So let's take a look at the kernel. Kernel is the next component that we need in our process of refactoring. And the kernel is, it's one of the components that has a dependency, and in this case it's a dependency on the event dispatcher component. I'm going to explain that in a minute. And what it does, it makes the work easier to handle all of this together. It creates a predefined workflow, if you like, to transform a request into a response. It's event-based. That's why it needs the event dispatcher component from Symfony. And it triggers a series of events to hook into. And setup could look like this. You create an event dispatcher. An event dispatcher is something that is able to notify other objects or its so-called subscribers of events that are happening. In this case, we register a router listener, and the router listener needs the matcher, because what it does is when it gets notified of a new request, it looks at the request, tries to match the route. And another thing is a controller resolver. This is the thing that encapsulates this, kind of awkward callable logic that we had before, which is going to make this much cleaner. And then lastly, we create the kernel itself and hand over the dispatcher and the resolver. And after that, we have the very three lines that you know from, or might know from, the Symfony 2 front controller. Again, we create the request from globals. We convert the request into a response by calling kernel handle, and then send the response to the client. So what is this controller resolver? So far, we have seen two ways of storing a controller information in our matched route. The first way was to simply store a callable itself, which can be done. For example, Silex does it this way. Or you could store different controller information as strings, as we did in this case. The point is that the controller resolver is there to look at that information at this underscore controller value, and is able to get back with a real controller instance, a callable. So this method get controller, all it needs to do is hand back a callable controller, or null if it doesn't find any, which of course means you should should display some kind of 404 page. There's a second method, get arguments, that should extract the arguments that should be handed to the controller from the request. If you look at Symfony, the full stack framework, this is what extracts the attributes from the route and injects them into the controller method. The feature that you can use. Okay. So next. The next thing that we need to get rid of is the hard-coded stuff. Our original legacy code had all kinds of configuration information, database access, and so on, hard-coded. into the PHP files. So we want to be able to configure that. And Symfony has a configuration component for that. It's called the config component. In fact, there's also a YAML component, which is just used as a helper. It just is able to parse YAML files, which PHP cannot do natively. So it's, in this case, we are going to use this as a helper. But, well, what does this config component do? What it does is it locates, loads, and caches config files. Optionally, I can use it to validate config files and merge cascading config sets, which is a feature that you can, for example, see in Symfony 2 full stack, where you have several YAML files per environment, and you have a base YAML file in which you define your base configuration that is valid globally, and then per environment just merge in additional config files that change those pieces of configuration that are different for this specific environment. Using the YAML component is really easy. You simply take a config path, hand it over to the parse method, and you end up with an array. Simple as that. It makes sense. It kind of makes sense to improve this a bit by caching, in which case you can use one part of that component library called the config cache, which takes over the cache path and a debug flag. Debug to true, setting debug to true means it is going to check the file time if the cache is still valid. If you set debug to false, it will never check. It will just assume the cache is valid, which means that you need, for example, when deploying your application, to clear the cache manually. But this is, of course, a little performance improvement. But we are going to use this in debug mode. And once we have this config cache instantiated with the config cache path, we can ask it if it is fresh. It's fresh means it's still valid. If it is fresh, we would simply require that cache path and take what's in there, what's returned, as the config values. The format of this is up to you, right? So what we are doing to save this is a simple export of the values that are parsed from the YAML file. So what we end up with is a file that returns a PHP array. And we write that to disk using the config cache write method, and have created a very simple configuration cache. So again, what happens? Symfony checks if this file is still fresh. If it's fresh, it's going to simply require that, and I end up with a simple PHP array. If it isn't, it is first going to create that file and then hand me back the results. Okay. I'm getting to the bottom of the list. One more thing is to show you is the console component. And the console component is, well, it's simply a different interface to our application. So far, we have access through HTTP. Maybe we need to be able to access our application from the command line as well. And for that, we can use the console component, which allows us to easily set up CLI scripts, have certain features like parsing of options, of arguments, and so on, outputting help texts, even interactive dialogues. I can easily create interactive dialogues with this. And to do that, all I need to do is, well, extend a base command class. And the command class that I'm writing then mainly consists of two methods. The first one is configure, which, well, tells Symfony what options are allowed, what arguments are allowed, the help text, and so on. In this case, I'm calling this to do :add. I add a description as a help text, and I add an argument called title that I can access later on in the second method that I need to implement, and that would be the execute method. The execute method is called when I actually run this command. It gets an input, which is the data that I've passed to it, and an output, so I can write back to the CLI. And in this case, I'm using the dialog helper to create a question that the user needs to react to. And what the user enters is stored in the title variable. And then I can use that to interact with my business model, and in this case, for example, create a task. What it looks like is then is this. I get the question, I can enter something and get feedback for that. The application itself, after I've written that command, is just an instance of the Symfony Component console application. I, of course, need to somehow create my business model, instantiate, connect to a database, whatever, and then create the application and add several commands and then call run. And what I end up with is this might or should be familiar to you because you hopefully all have used Composer, and Composer uses the Symfony CLI component. So this is why it looks like for Composer, because Composer uses the Symfony CLI, and if you call the CLI console without any arguments, this is what you end up with, which is a help, which consists of a general part of the features and a list of the commands that you've registered together with a help text that you can run. And the CLI provides you also with a help feature. If you call console help command name, then it will output the specific information for that command. In this case, it's the title argument. It tells you that there is a title argument and what it is. This is the description text that you added in the configure method. Okay, now that's it for the components, but there's one more thing I'd like to show you, because that gentleman over there in the white shirt, yes, you, yeah. Ryan did a talk yesterday where he showed you how to build something similar just with different components, not Symfony components, but general PHP components. And he used a DSC for that. And so, oh, sorry, this doesn't work at all. Oops. Okay, so, and this is the example code that you can download. I'm showing you the URL later on. And well, one thing in advance, before I'm going to start to skip through this code, in this case I'm using Silex, which is not Silex, Pimple, which is a small dependency injection container that is very well suited for this kind of stuff. There is a dependency injection component from Symfony. It would have probably been more consistent to show you that because it is a Symfony component and Pimple is not. But to be honest, it's really complicated. And the reason why it is because it is suited for a lot more complex and larger jobs. So you can use the dependency injection component on its own, but you should do so if it's a really large project with lots of services, or if you're writing your own framework such as the Symfony full stack. Then it makes sense to use that dependency injection component, because that dependency injection component, together with a config component, allows you to do things like write service definitions in YAML, cache those service definitions, even manipulate services differently, stuff like that. But for a regular small PHP project, especially when refactoring stuff like we do, this is just overkill. It's over-engineered. So for this purpose, so it's much better to use Pimple. And this is just the bootstrap file where I use Pimple to set all of this up, what I've explained just now in the slide so far. And again, I'm going to provide you the URL to this so you can check this out and run this on your own. What I'm doing here is, well, I didn't talk about the repository. The repository is simply the database access. It is not a Symfony component. This is why it wasn't on the slides. This just talks to the database and loads tasks and saves tasks. And this is the router setup, which is very similar to the setup that I've just shown manually. We simply register the router as a service, similar with the templating. Registering templating as a server with the configured files. What we do here, what goes beyond what I've shown in the slides, is we add helpers. These helpers provide the templating engine with functionality like the slots, like the router helper is able to generate routes, which the templating cannot do on its own, and so on. We register the event dispatcher, the controller resolver, and finally the kernel. And the kernel is the central service, of course, that we are going to use in our front controller, which then is rather simple, where we include all the bootstrap and then have the container and simply, again, create the request from globals, take the kernel from the container and run it. Okay, again, this is available on GitHub. What do we see so far? I've left out a lot of components, of course. This it just would not fit into a single talk. So I selected those components that make sense for this kind of legacy application, which are describable or which we can do in this time. But there are a lot more, of course. There's form and security, which are probably the most complex components that we have, which also can do the most for you. They are tremendously useful, but they would require at least a single talk, each one of them. So this is why we didn't include them. But take a look at form security. There's a validator component that makes it very easy for you to validate business objects. The event dispatcher that we only glanced at. A finder that can interact with the file system. A process component that can run other system processes from PHP. Property access. Options resolver that you can use to parse options arrays. We've seen console. I've talked about dependency injection container. There's a stopwatch that you can use to time PHP parts of your code for debugging purposes and performance tuning purposes and so on. For all of these components, there's a documentation on the Symfony website. We have a dedicated section for the Symfony components. There's example code for this talk. Again, I'm uploading the slides later on, of course, and tweeting the URL, so you can go there. This is on GitHub. It's a running example. It's slightly more complex than what I've shown here to incorporate the Pimple container, and but it's runnable, so you can see all the steps that I've shown you and run this on your own. Okay, that's it. Thanks you.